Good morning, everybody. Happy Wednesday. Thank you for coming today. Today, homework assignment 1 is due. If you don't mind just passing it forward, I'll come around and collect those from you. This is a little different. It's the only time that that I'm going to ask you for a hard copy of stuff. It just allows me to get to know people a little better, because if I have to physically hand things back, then I got to come by and look at you, etc. So thank you. If it seemed straightforward and easy to you, good. If not, we'll talk about this for sure. Okay, so if you got questions, I'll review this with you next time. Thank you. Folks, this is the JD Easy robot that you saw going on before class there. And it is app controlled like many things, but it also is somewhat autonomous. This thing can be, quote, programmed. We did a little bit of programming with the Ozobots. We're going to come back and do that again. But unlike the BB-8, this thing is somewhat autonomous. We can give it a set of instructions, an algorithm, and then we can have it interact with its environment and have at it. This robot is about $500. I think that was the retail price of it. So yeah, a little pricey, but you saw it doing something kind of interesting, huh? Good birthday present for your niece or nephew? Maybe not. All right, good. Current events today. Folks, I apologize that I don't have my big screen here. I got plenty of other things to do. I kind of hope other people will help with some of the technology around here. It hasn't happened yet. Maybe we'll get that back sometime. So strain so you can see these little ones. Intel smart glasses. Maybe you remember a few years ago with Google Glass, the so-called one of the first consumer augmented reality devices. You wear them and it projects a little image there. The Intel smart glass, they sort of look like glasses, and they actually will project images into your eyeball. That's weird. Okay. So this reviewer says, wow, really cool. Doesn't look weird like Google Glass. Feels like a pair of glasses, but it will project things into your eyeball. Wow. You probably noted, and just in case you haven't, that battery technology is really interesting. Most devices use a lithium-ion type of battery, and they're pretty powerful, and they're also a little bit, what should we say, fragile. Lenovo has had to recall a whole bunch of laptops. They haven't burst into flames yet, not like Apple iPhones and Samsung Galaxies. But they noticed there was sort of a production defect in here. So I always tell folks, good idea to keep an eye. I mean, if your device feels really, really hot, yeah, put it in the freezer. Do something about it. All right, onward. I do share a bumper sticker with you. They're mostly supposed to be funny, except for one time each unit, I'm going to share a bumper sticker from one of the branches of the armed services. This was the Navy slogan a couple years ago, life, liberty, and the pursuit of all who threaten it. I'm going to ask a favor of you. The 4 times I do this, I'm going to ask a favor of you. If you know somebody who has served or is currently serving in the military, will you do me a favor? Send them a note. Just say, thanks for your service. That's all you have to do. Trust me, they will appreciate it. If you know somebody who served in the armed forces, this is my dad. He was a highly decorated World War II veteran, served on carriers. He's no longer here. He'd be 98 if he was still here. But if you know somebody who served or has served, do me a favor, just send them a note. You don't have to say anything more than just thanks for your service. They'll appreciate it. Thank you. Onward. Roman numeral 5. Today we're going to take another look at the grand ideas of computer science, but I want to see them in a context. We've talked about algorithms, abstraction, and automation. There are more, and we'll see. You can read about them today, and we'll talk about them more also. But the reason I'm doing this is because the meaning of anything is connected to its origin. If you want to understand computer science, we got to look at its origin, and its origin is grand ideas. Oh, can't read the little cartoon, you know, top of the mountain, the Swami. What's the meaning of life? I don't know, the computers are down. If you're following my notes, I'm going to skip part A, and I'm going to be skipping some other parts around this. Stuff you likely know, or you can easily read. So let's get into it. Cat B, problem solving. Computer science, concise definition? You don't want to say it because it's sitting right there staring at you. I don't blame you. Did you say, oh, no, wait, you just think it. Think it out loud. Problem solving, that's it. Good for you. Algorithms, the concise definition of an algorithm is? Instructions, thank you. Instructions, and I'm just going to add for solving problems. Makes sense. Algorithms are instructions for solving problems. So we're going to be focusing on some algorithms today, and in context we'll see abstraction and automation playing through it. But let's focus on algorithms. Probably makes sense if computer science is all about solving problems, and algorithms are methods of solving problems, then another way of thinking about computer science is the study of algorithms. If we're involved with problem solving and algorithms do that, then sure, computer science is the study of algorithms. Now I'm going to share 4 things with you about algorithms. This is going to sound horrible. Hang on, work with me, it's not that bad. Computer science is the study of algorithms including A, their formal and mathematical properties. Their formal and mathematical properties. This course, CSC 150, Foundations of Computer Science, satisfies core math requirements. So you can take this course and not have to take another math course unless you're a math major or minor. And because of that, we've got to talk about some formal and mathematical properties. Computer science is all about that. Does this sound horrible? No, it's not. You're going to see. Another way of expressing that is to say, if we're going to come up with an algorithm, we have to have an idea. This is all about the idea of problem solving, the idea of algorithms. Let's go through it and then you'll see it in a context. So, computer science, the study of algorithms including their formal mathematical properties. Geoclock. Somebody had to figure out what's that formula. You know, what time is, when is the sun rising? Thank goodness it's going to start rising before. Folks, I'm up before 6 a.m. and I hate it when the sun rises at 7:30. It's like really dark. Thank goodness the sun is going to rise before 7 o'clock sometime soon. Whew. Sorry. Somebody, the geoclock programmer, had to have the idea of what's the formula, what's the mathematics behind that algorithm. Computer science is the study of algorithms including B, their hardware realizations. Their hardware realizations. We've mentioned that hardware provides the capabilities of a system. What is possible for this to capabilities? Is that right? There are a lot of I's in that word. Another thing we have to understand is how are algorithms carried out by hardware? The hardware actually does it. Cool. Computer science is the study of algorithms, including, thirdly, their linguistic realizations. What's that mean? Linguistics is language. The language of computer science is software. And we know that software provides the abilities of the system. Computer science study of algorithms, including their linguistic realizations. What I mean by that is the software abilities. Taken together, I'm going to refer to this aspect as implementation. If we're solving a problem like where the sun is shining, first of all, we begin with an idea. What's the mathematical formula? What's the algorithm? How is that going to work? Now, the next thing I have to do is realize there's some hardware that's necessary. Got to have input, got to have a processor, etc. And we're actually going to have to create the algorithms from this idea. So the geoclock programmer wrote the algorithms, wrote the software for a specific piece of hardware. One more aspect of the study of algorithms, and that is, finally, their application. That's probably the easiest aspect to understand. It's what we've been working with for 20 plus years, the application of all this technology. I'm going to refer to this as interaction. Okay. There's the background. Let's see this in a couple contexts. We're going to take a look at two different algorithms today. But first, in Chuck Norris Windows, the Start button is named Finish. Because Chuck Norris doesn't start things, he finishes them. It's okay to laugh. All right. Creating algorithms is hard. Trying to create an algorithm is difficult work. We're going to experience this. It's nothing to be scared of. Anything interesting and worthwhile takes a little bit of effort. But rather than creating algorithms today, we will do this. We're going to do this in a couple different ways in this class. And we have to think about the idea of it, how we're actually going to implement it, and how other people are going to interact with it. But for today, let's just follow a couple algorithms. Let's not worry about the idea and the actual implementation. Let's just focus on the interaction. You ready? The first algorithm we're going to look at today is the algorithm to compute the date of Easter. Easter is a variable holiday. Unlike Christmas, Easter doesn't fall on the same day every year. You know that. Christmas is always December 25th, but Easter can fall on any date from March 22nd through April 25th. So, when is Easter? How would you figure that out? Well, just Google it, man. Okay, how do they figure it out? Oh, a little bit of background. If you haven't had Religion 100 or 110, or you're not a Christian, you may not have any idea what the heck is Easter. For a Christian, Easter is the most important holiday. It's the entire pinnacle of Christ's work. Easter is a celebration of Christ's victory over sin, death, and the devil. It's when God himself rose from the dead. So, when is Easter? Oh, shoot, darn. You know, if you walk into our chapel is set up with the bookends of Easter. When you walk into the chapel of Christ Triumphant, what you see walking in over the altar is, this is Good Friday, Christ crucified. When you turn to leave, what you see, by the way, that used to be, when it was School Sisters Notre Dame, this used to be a stained glass of Mary. Okay. When you turn to leave, you see Christ Triumphant, Christ rising on Easter morning. So, when is Easter? The Council of Nicaea in 325 set the date of Easter as follows. Oops. The Council of Nicaea said Easter is, I think I know. Easter is defined as the first Sunday following on or after the first full moon, following on or after the spring equinox. Got it? Okay, good. That's the date of Easter. What? It has to be a Sunday because Christ historically rose from the dead on a Sunday. And the date of the full moon and the spring equinox, that relates to Passover, and that's when Christ was crucified. So that's it. Got it? Good. How can I figure out when that is? By the way, Luke records that when the women went to the tomb on Easter morning, why didn't the men go? They were too afraid to go. When the women went to the tomb on Easter morning, they were met by an angel, and the angel said, "He is not here, he has risen." I hate all these depictions, all these paintings. I know you can't see it very well. You ever see all these paintings of angels? Angels always look like these fluffy little feminine things. Well, angels are not like that at all. Angels look like Chuck Norris. And I'm not joking, okay? You read the description of Michael, okay? I said this for a number of years. I said, I need somebody to draw me an angel that really looks like an angel. And a couple years ago, Rachel Plautz drew this, okay? That's an angel. Angels come to take names and kick things, okay? They're just, All right, so how do we figure out the date of Easter? There's an algorithm. A number of people tried to create a formula, an algorithm for this over the years, but they all had some problems. As far as we know, this algorithm is correct. It's pretty recent, 1965. Right? Are you ready? Oh, gosh. Folks, I apologize. Without my 8-foot screen, I'm sorry, I know you can't read this. It's in the reading, it's in the notes. We'll try to step through this. Yeah. And that isn't even all of it, thank you. Yeah, there are 10 steps. All right, let's talk about some of it, and let's do it. Are you ready? A couple things to say about this algorithm. Note these two things to begin with. First of all, this algorithm uses arithmetic operations. If you look at it, you see add, subtract, multiply, divide. This uses arithmetic operations. We know computers do that. And the second thing that's new is this algorithm does something called sequential execution. Sequential, sequence, that just means in order. So guess which step we do first? 1, then guess which one? 2. See, it's not that hard, right? It's really not that hard. There are other ways of doing it, and we'll see. All right, are you ready? This is what the algorithm says. It says, choose any year of the Gregorian calendar. Let's pick 2025. And you say, well, why not pick this year, 2018? Oh, I'm going to ask you to do that. Right? So pick any year and call it X. X. In computer science, this is called a variable. X is a variable. Now, you may be able to do this in your head. I can't. If I'm following an algorithm, I always have to write things down and label it. So when it comes to variables, I just draw a box, and I label it X, and then if I need to remember anything in that variable, I'll just write it in here. There we go. This idea of variables is familiar to you. You've worked with algebra before. Computer science is based upon that same concept. A variable, as the name implies, is a placeholder where the contents can change, vary, perhaps. Now, when you look at the algorithm, you can see that in step 1 it says take the current year and divide it by 19. Warning, this is not calculator division. Computers often do not do calculator division, mainly because they're not calculators. This is called modulo. It's okay, it's actually simple. Remember when you learned how to divide in 3rd grade? Teacher started with easy things, 4 divided by 2. See, there's 2 groups of 8 divided by 2, 4, yeah. And then the teacher threw a curveball, 7 divided by 3. Let's see, 2, no, 3, no, wah! So 7 divided by 3, you said, is 2, remainder 1. That's actually a real thing. It's called modulo arithmetic. So, in the algorithm, when it says take x divided by 19, we know x is 2025. So don't do the calculator thing. If you plug it into your calculator, you get the answer of 106 point whatever, whatever, whatever. The actual process is this. Oh, did I go too fast? I did. The actual thing is 19 goes into 2025 106 times evenly, and then there's a remainder of 11. 19 times 106 is 2014, and you have 11 left over. The algorithm says you want to remember the remainder, that 11. How do I remember something? I assign it, I put it into a variable. So, at this point, after step 1 in the algorithm, there are 2 variables I'm keeping track of. X, which is 2025, and A, which is the remainder after that division of 19. And how much is that? 11. Woo. When you initially looked at the algorithm, you said, well, how can you do anything? It's, A and B and C. What's happening is we're going to determine these values as we move through the algorithm. Okay? All right, so that's step 1. You're saying, well, what about that 106? You just ignore it. We don't care. We'll see there are other steps when we care about that and some that we don't. Okay, step 2 says take x. What's x? 2025. Again, divide it. Ooh, but this division is modulo arithmetic. Divide. Oh, we could probably do this one in our head, right? 2025 divided by 100. 100 goes into 2025 20 times evenly with a remainder of 25. Right, 100 times 20 is 2,000. So step 2 of the algorithm, sorry, you got to look on your sheet if you got it, says x divided by 100 gives me a quotient, b, and a remainder, c. So if I was really trying to follow this, I'd have to write all this stuff down. I can't keep it in my head. So b is 20, c is 25. Cool. The next step says take b, divide it by 4. Easy numbers, right? 4 goes into 25 times evenly, exactly directly. You're saying, well, what's the remainder? The remainder is 0. 0 is a number. It's a value. Sometimes people get confused. 0, what do I do? It's a number, just like anything else. So in this 3rd step, notice that we again have a quotient that we're going to call D, a remainder we're going to call E, and there's some actual values there. As you step through the algorithm, 1, 2, 3, 4, 5, 6, you're going to be using some previous values, just like we had to remember B here, what was B, and then we're going to be creating some new values, like D and E. One more step, and then I think you'll have seen what needs to happen. The only thing tricky about step 4 here is something called precedence. Step 4 says 8 times b. Have to look back up. B was, I didn't write it down. B was 20. 8 times b plus 13 divided by 25. There's a so-called mathematical precedence. If you're a math major or minor, you know what this is. When you have mixed operations like multiply, add, you always do multiplication and division first before you do any addition or subtraction. Now in this case, you're saying, well, if I did it left to right, it'd be okay. Yeah, you're right. But if it turned out that the algorithm said add first and then multiply, I wouldn't do it left to right. I would do the multiplication first and then the addition. That's called precedence. Now, at this point you're thinking, how does this give me the day to Easter? What's all this stuff mean? In essence, what the algorithm is doing is trying to compute when the full moon happens, when a Sunday happens, and things like that, based upon the fact that the moon is about a 28-day period. We're not going to investigate that. We're just trying to follow it. Enough work just to follow the algorithm? Yes, trust me, there will be. If you go all through it, and after step 10, the algorithm says, okay, look back at 2 variables, P and N. P will be the day, N will be the month. So you notice N is 4. N could only be 3 or 4, March or April. In 2025, Easter will be April 20th. Cool. Easy? Yeah. This year, Easter is not April 20th. This year, Easter is a different date. You might want to figure out when that was. I hate the term Good Friday. Why? My Lord was hanged on a tree that day. If you're going to be hanged on that day and he volunteered to take your place, how would you feel? Good. Have a nice day. While you're thinking about this, let me just share something with you. I checked with the chair of theology, Dr. Pavla, and he indicates that they don't usually talk about this in Religion 110. If you've had Religion 110, you know what Easter is. But apparently you haven't heard about the rematch. You never talk about the rematch between Jesus and Satan? The rematch happened just a few years ago in the 21st century when Satan came up to heaven, banged on the door, and the archangel Michael answered. Now remember, archangels look like Chuck Norris. And Satan says, I got ripped off 2,000 years ago. That wasn't a fair fight. I demand a rematch. And the archangel Michael sighed and said, okay, what would you like to do? And Satan said, I don't care. You make it up, but I want to have another crack at beating Jesus. So Archangel Michael said, well, it's the 21st century. Let's have a programming contest. Are you up for that? Satan says, okay. So on the appointed day, Jesus and Satan arrive. The Archangel Michael leads them into a room. There are 2 computers. There's a Mac and there's a PC. I'll just let you guess who went where. And they both sit down, and the Archangel Michael says, okay, here are the rules for our programming contest. You will have 60 minutes. I am going to give you an idea. You then have the rest of the time to implement that idea in hardware and software. And at the end of the 60 minutes, I'm going to interact with each of your apps and determine which one is better. Okay? All right. So Archangel Michael explains it. Jesus and Satan think for a little bit, and then they start entering code furiously into their respective computers. At 58 minutes, 45 seconds into the programming contest, the power goes out. Just for a split second. Do you remember what happens if the power goes off to a desktop computer? Satan jumps up, starts yelling and screaming, what happened? What went wrong? This is not fair. Well, finally, the Archangel Michael looks at his watch and says, okay, time's up. Satan, do you have a program? You know I don't have a program. The power went on. I lost everything. Oh, that's too bad. Michael turns to Jesus and says, "Do you have a program?" "Yes, I do." Of course, when Michael interacts with it, it is perfect. Satan said, how do you do that?" Michael says, "Oh, I thought everybody knew. Jesus saves." Okay. Folks, don't forget, when you're working on a desktop PC, be sure to save your work from time to time. Okay, before we look at this next algorithm, I know that was kind of a whirlwind. I wanted you to see it, and now I'm going to ask you to go back and take a look at the Easter algorithm. Yeah, there's a lot of steps there, and following through will be interesting. The text shows you, I think it's 2025 fully. I am going to ask you in homework assignment 2 to follow this and determine the date of Easter for 2018 this year. Fun. Yes, they're all there, you bet. Nope, you got to guess what they were. Kidding. Yeah, they're all there. Imagine trying to create the instructions. No, let's just follow algorithms today. Good enough. Here's the second algorithm that we'll look at. GCD, greatest common divisor. You remember this some point in time in the past in a math class. The GCD is the largest integer that will evenly divide two other values. For example, 56 and 18. Does 2 evenly divide 56 and 18? Yeah. Is it the biggest number that evenly divides 56? No, it's not. So question, what's the greatest common divisor? Well, 2,300 years ago, an old dead Greek dude, he wasn't dead at the time, Euclid, devised a formula, an algorithm for computing it. Here it is. And again, this is in the notes and it's in the text. I'm sorry, it's small. First of all, you'll say, oh, well, this is not as long as Easter. And that's true. But you know what? I think it's a little more complex because it has two additional ideas beyond sequential execution. Let me tell you some things about GCD, and then let's follow it. Although it's shorter, I kind of fudged. It says 3, but it's 3A and 3B, and there's some sub-steps in 3, so I don't know how many steps there really are. But it's shorter than Easter. But it's more complex. Here's why. First of all, this algorithm entails repetition. You're not just going to start at 1 and end at 3B. Can you see this thing at the end of 3A that says repeat at step 2? You might repeat some steps multiple times. Secondly, this algorithm employs something called selection. Selection is a choice. Do you see 3A and 3B? You're not going to do both of them. If the remainder is not 0, do this. If the remainder is 0, do something different. You have to choose. You have to select what's going to happen. And thirdly, this does use arithmetic operations, but it also uses logical operations. There's a comparison. If this is not 0, that's a comparison of some type. Let's follow it through. Again, those same ideas of variables, so I'm going to just draw boxes, or maybe I'll just fake it. And we need to remember values. And this, you'll actually see why we call them variables. Once we put a value in a box in Easter, it didn't change. But once we put a value into a box in GCD, it might change. All right. Let's figure out the greatest common divisor of 30 and 18. Again, 2 evenly divides, by evenly I mean remainder of 0. 2 evenly divides it, but that's not the biggest value. So what is, I bet you can do this in your head. I bet you could just look at it and say, yeah, I know. But let's see what the algorithm does. Step 1 says the following. You have a variable called larger, a variable called smaller. By the way, make a big box if you're going to follow along here, because I'm going to cross some things out. And guess what? The bigger value goes into, the bigger value goes into larger, and the smaller value into smaller. That's step 1. Step 2 says, okay, divide, warning, that's modulo, quotient remainder. Don't pull out the calculator, won't help. 30 divided by 18. 18 goes into 30 one time evenly with a remainder of 12. Right, 30 minus 18 is 12. The quotient, I'm going to ignore that one. I don't care. But I do want to remember the remainder. So 18 goes one time into 30 with 12 left over. That's the remainder. I'm going to keep that. I'm going to remember it in a variable called remainder. Now, step 3, I got to make a choice. Is remainder 0 or is it not 0? The answer is it's not 0. 12 is not 0. That's true. So 3a, if 12 is not 0, that's true, then 3 things happen. Are you ready? These are weird. Step 3a1. Take the value of smaller and shove it into larger. Computer scientists call this an assignment. And I'll oftentimes say, assign smaller to larger. Okay, well, wait a minute. What happens to the value in larger? It's wiped out. If I'm going to assign smaller to larger, larger used to have 30, it's wiped out. I'm going to put 18 in there now. Okay? So that was the first step under 3a. Assign smaller to larger. Second step under, there it is. This is called assign. You can think of it as replace. Second substep under 3a, we already did that. Second substep, take remainder, assign it to smaller. Smaller used to be 18, that's wiped out. Smaller is now going to contain 12. And then we're going to repeat. We're going to go back to step 2 and do it. You're saying, well, we already did step 2. Yeah, but when we did step 2 the first time, we were dividing 30 and 18. Guess what? We're going to divide different values now. Go back to step 2. Step 2 says still the algorithm larger divided by smaller. But notice larger and smaller are different values. So now 18 divided by 12. 12 goes into 18 one time with 6 left over. So guess what? This remainder that used to be 12, now I'm going to put the new remainder in there, 6. And then I got to make this choice again, selection. Is 6 not equal to 0? Yes. So now I'm going to do that again. Take the current value of smaller, which right now is 12, assign it to larger. So this is going to move up here. Next substep, take the current value of remainder, assign it to smaller, and then repeat at step 2. This could potentially go on for a while. We are going to end it now because, as you can see, when I divide larger 12 by smaller, 6 goes into 12 2 times. That's the quotient. Remainder 0. That's the 3rd time we've done step 2. Now I got to make this choice at step 3. Now remainder is 0. So I can do 3b rather than 3a. So 3b says that the remainder is 0, then your greatest common divisor, let me just draw a new box. Your greatest common divisor is the value of smaller. So I'll just assign smaller to GCD. I'm done. And indeed, the greatest common divisor of 30 and 18 is 6. 6 divides each of those evenly. There's no bigger number. 8 don't do it. 29 don't do it. 29 is bigger than 18 anyway. Right? Yeah. That was fun. You would like to try this. We're going to try this now. I'm going to ask you to follow I'll put the algorithm up. I'm going to ask you to do this. Don't panic. You won't have to turn it in, but trust me, if you don't try this out right now yourself, you're not going to know what you don't know. So we got to do this. So let me get you started. I'll show you the algorithm in just a second. You could do this in your head, but do the algorithm. So larger is going to be 35. Smaller is going to be 14. At the end, I'm going to ask you, not only for the answer, but I'm going to ask you, how many times did you do step 2? I'm sorry, I know that's tiny. Can you see it up here? Go through the algorithm, find the answer, and tell me how many times step 2 was done. Are you ready? Go. Will it bother you if he's dancing while you do that? Don't forget that the second time you're going through there, you've got different values. Those are going to change. That's incorrect. Hope you did better than the robot at doing the GCD. He was going to congratulate you, but apparently he is thinking. if you didn't have time to get all the way through it, it's okay. I wanted you to think about it, struggle with it a little bit. Okay, so here's step 1. Step 2, divide that by that. How many times does 14 go into 35? 2 times with a remainder of 7, okay? 35 minus 28 is 7. So the remainder, first time we do step 2 is 7. The 2, it just is gone. We don't care about that. We don't care about the 2. So 3a, is this not 0? Yes, this is not 0. So we got to do this assign thing, change. Smaller is shoved into larger. The 35 goes away. The 14 comes here. Remainder is shoved into smaller. The 14 goes away. 7 comes here. And then repeated step 2. Step 2 says divide larger by smaller. 7 goes into 14 2 times evenly. Remainder, 0. Don't forget, we're going to have to put that 0 there because that's what stops the algorithm. So now we get to step 3 and we see 3b is a 0. So we say if the remainder is 0, the GCD is smaller. And indeed, 7 is the biggest number that will evenly divide 35 and 14. So we did, how many times did we do step 2? Yeah, thanks for saying that. We did it twice. You always do it once, right? And then you repeat. Yeah, don't just think that the repetition, I repeated once. How many times did I do step 2? I actually did it twice. The first time, which you'll always do, we repeated. We did it the second time to get that remainder of 0, and then we ended. So for your good work, let's see, wave. Okay, you did good. You did good. That's good. That's it? Wow. All right. Euclid, the inventor of the GCD algorithm, did other things too. Something with a circle. I made your favorite, Euclid, pi. Pi. Okay, sorry. We're going to be talking about other grand ideas. You look at the notes or do the reading, I've sort of introduced some of the other grand ideas. I knew I wouldn't have time to get through them today, but we'll discuss them in class sometime. Now, if you look online at Blackboard Learn, you will see homework assignment 2. Assignment 2 is due 1 week from today. Oh, that'd be my present to you. Valentine's Day, right? Today's 7th? Yeah. The 14th of February, 2018. You will not hand in things. You'll submit it online to Blackboard. I'm going to ask you to do 2 things. Probably bright enough to guess. Follow the Easter algorithm, follow the GCD algorithm. Do the Easter algorithm for this year. Now, you probably have to do the whole thing, but I only want to see 2 of the steps. You only have to list 2 of the steps that you submit. Step 6 and step 8. You're saying, I got to do them all. Well, you can list them all if you want, but I'm going to look at those 2 steps. You're saying, oh, it'll be, no, you know what? To do step 6, guess what? You can't just start at step 6. You have to start at 1 and 2 and 3. And then I want you to follow Euclid's algorithm for determining the GCD of, I forget, there are 2 numbers there. And then I'll just ask you what's the final value of those 4 variables and how many times was step 2 done. Okay? All right, good. If you've got questions about that, after you take a look at it, feel free to ask. I'll say some more things about it Friday. But have at it. Do 1 week from today. We are done. Thanks for coming. Have a nice day. Have a happy Thursday. See you on Friday.